researchers and all of those things. Most of these tools were developed by them. But how can we bring people? How can we develop researchers who can build things that are innate to Africa, innate to Nigeria, innate to Port Harcourt, and kind of develop new techniques for that and all of those things. So that's one of the key reasons why we are doing these things here. And the first one will be a contributor talk, of course, by Mr. Philip Obiorah, who is of course the is a PhD student at the University of Port Harcourt, computer science. And of course, you should know that credibility. In any case, he's also the co-lead of the Google Cloud Developer Community in Port Harcourt. So, Google Cloud Developer Community here in Port Harcourt is just a community of people who are interested in Google Cloud technologies, or community of developers, where by these communities just to network people around Google technologies, Google Cloud technologies, to see how we can help foster their growth as developers. And he'll be coming to talk to us on importance of scientific research in technology. All right, Mr. Philip.
Good afternoon, everyone. So we're talking about the importance of scientific research and technology. So that's my Twitter handle. So most of the time we embark on solving problems and without actually putting it down or doing it the scientific way. And then you find out that it's as if we in Africa are not inventing anything. But we do, but we don't put it down. There are so many inventions, but we don't even know that we've invented something. Somebody will pick up something and you just know there's no process, there's no documentation. So we just assume that nothing is happening. Now there are some people that are really badass and they come up with solutions, but it's not on paper. And then tomorrow again you'll see someone else with similar solution, and you feel like I did this thing now in 2012, but because you didn't write it down, no knowledge transfer. Right, so that's what we're talking about, important scientific research. So I hope that okay, so we need to let us understand the entire concept. So understand what is research, what is scientific research, break it down to technology, and then look at the importance of this, and then challenges researcher space, and then so let's begin. So what is research? What's the understanding of research so far? Oh, look at what it is like. Yes.
The research is actually an inquiry or investigation that is saying that getting knowledge or working on making something.
Excellent, excellent. This is an inquiry or investigation on getting new knowledge or working on an existing knowledge. Very, very, very true, very correct. So you can also say it's a process used to collect and analyze information to increase the understanding of a topic or issue, right? And then what we do when we want to have a question or problem we want to resolve. We have this problem. So let's think of a problem now. Which problem do you think we want to solve now? Let's think of one. Let's do one random problem. Eh? No, just think a problem we want to solve. Eh? Power supply. Okay, power supply. How do we? Power supply is big word. How do we have a stable power supply, right? In Nigeria. Good. Research. So we're going to research, right? So we have a problem now in our head, right? And then how do we resolve it? So we may already think of an answer to the question already. So if we start thinking of an answer to the question, how do we? So we have something already in our head. How do we solve? Do we can buy our own standby generator? Is that a solution? Okay, so we can start installing solar panels. So how? So start thinking of this solution right now. Then we may think of an answer. We may think the answer is obvious or common sense. So some people already think the answer is obvious. How to solve the power issue in Nigeria? How do we solve it? For those that may think the answer is obvious, how do you think we solve it? Eh? You have to do what? You have to on generator. Remember, looking at Nigeria, right? Everybody should buy his own generator. Yes. Okay, don't. So some people may think the answer is obvious or common sense, but we still have to subject our problem to rigorous scientific scrutiny. And then our knowledge remains little or more than guesswork or advice intuition. If we just think it just result to common sense. So you have to subject to scientific scrutiny, doubt a lot of things. Like you want to do a research on yourself, on human nature. First of all, you can even doubt whether human beings are, whether they exist. You can even doubt the existence first. Right? Subject it to scientific inquiry. Take yourself out of it. All right. Okay, so let's proceed. Okay. Not the next. Okay, yeah. So the first priority is to formulate your question. The first thing is to formulate our question, right? So this is what our question here. And then figure out how we are going to answer it. Have others answer it. So what's our question here now? How do we solve the power issue? Now, how do we answer this? We start looking at have others made an attempt to solve power problem in Nigeria. Who have made attempt? So we now go out and start digging out materials, papers, newspaper, what people have done, efforts who have made, solutions who have, recommendations, proposals who have done. And then we now say, okay, look at how our own proposal will fit into what others have done. So we are not starting from the scratch. We first look at what others have done, and then see how we can key in. Look at what they suggested that did not work. Maybe they proposed solar panel, and then the batteries are not lasting. Maybe lasted for like a few months, and then it didn't work. Or they say we should build more dams, and then, or it could be, Nigeria is exporting power. So exporting power. So it could not even be power generation as a problem. It could be distribution, transmission. So all these things are now subject. All right. Then how does so we now look at how our proposal fits into what others are done, and then how we know when we have answered it. So how do we actually know when we've actually answered the question, we solved it, we come up with solution? How do we know? We have to do some experiments, right? Right? Good. And then we can now present the answer. Okay, so now let's look at scientific research. We'll be talking about research. Now let's look at scientific research. So when we look at science, we're looking at research conducted for the purpose of contributing towards science by systematic collection, interpretation, evaluation of data, and that is planned in a manner that is called, that's what we call scientific research. So when we conduct research for the purpose of contributing to science, and they collect data in a systematic and interpret this data in a systematic manner and evaluate it, we are doing what we call scientific research. Now, researcher is one that conducts that research. Okay, now, when we explain this, the different types of scientific research, so we have basic research, applied research, quantitative research, and qualitative and quantitative. So regardless of the discipline, I know some people are coming from biological sciences, such a discipline, sciences, physical sciences, medicine. Very good. Awesome. So where do you think, what type of research you guys engaging? Bachelor of it. Are you sure you can't be bachelor of it? Okay, so when we explain it, you'll be able to tell me which one you do in your department. You will know where your department falls. You can't do all. Okay? So now let's look at basic research. So basic research is what we call pure research or fundamental research. In this case, the aim is to understand theories, is to add to the theories, to improve scientific theories for improved understanding, prediction of natural order or phenomena. Just for instance now, okay, what are some, so give me an example of the theory, the scientific theory. Newton's law of motion, what does it say? Okay, just one of those laws, or gravity or whatever. So in this case now, you're looking at coming out with another law again. Maybe you're saying that whatever goes up can continue to go up as long as nobody is acted as it. We have to prove it, right? So it's not actually you're not actually doing that for financial purposes or you are actually adding to the body of knowledge. That's pure research. You're not doing it to build a product. You're understanding nature, the laws of nature. You want to understand and add to the already existing body of knowledge or to modify it. Maybe maybe you just notice that there's something wrong with, or you come up with another theorem, math. You get pure research, pure, fundamental. Now the next one is applied research. So this is now applied research using those scientific theories of what basic research, right? Of fundamental research to develop technology or techniques to intervene and alter the natural order of phenomena. They are often driven by curiosity. So basic research fuels applied sciences innovation. So applied sciences makes use of those scientific theories already formulated by basic research. In that case, we want to now, so let's say maybe to solve Nigeria's problem, we may think of this, we just think of a device that combines both solar, hydro, what again? Wind. Just imagine Just come up with something. So we can be thinking of that awesome device that will solve our power problem. Now we just keep it, and then as the sun is shining, it's charging, wind is blowing, something is happening, children are playing, run around it, it's tapping some energy, and then, you know, so that's what we can apply research. So this is where you're doing how to do that. So those in computer sciences or those in technology, we actually be doing more of this research, to actually innovate stuff, and then to develop what technology. So we do more of what applied what research. Then quantitative research. So this is a scientific research method of observation to gather numerical data. This type of, okay, non-numerical data, sorry, because it's what? Qualitative. So this type of research refers to the meanings, concept, definition, characteristics, metaphors. Okay, like right now, just like if someone wants to do research on people's perception to what? You guys in medical sciences. To what? Okay, people's perception to available contraceptive methods, or people's perception to those living with HIV. You want to know how people treat them, right? You're not, data you're getting, there is no numbers. You're doing interview on one interview, getting feelings, right? Positive, negative reviews. They are not numeric. The expression on their face when they hear HIV, qualitative research. Are you seeing that? Good. Then the next one will now leave us with the one with numbers, which is what? Okay, this model is 60 under qualitative. This research answers why and how a certain phenomenon may occur rather than how often. So it's looking at why did it happen rather than how often. So, all right, so we've seen that. And then now let's go to the quantitative research. So this method of research relies on measuring variables using numerical systems. So we are looking at numbers, analyzing these measurements using a variety of statistical models, and then reporting relationship between these and association among the studied variables. So in this case, we want to look at how many people have HIV in Nigeria. We are doing a quantitative research, right? So we want to know the poverty rate in Nigeria. These data numbers are gathering. How many people earn more than $1 a day? How many people earn less than $1 a day? How many people eat 3-star meals a day? You want to, when you get all the data, you want to know the poverty rate. How many people can afford so and so products? So in this case, you're looking at quantitative research. So now that we've known the different research areas, you'll be able to know where your field falls in, regardless of the department. So that when you're defending your project and they ask what kind of research it is, you'll be able to tell them, okay, this is a quantitative research, it's a qualitative research, or this is applied research. Or if you're doing the basic research, fine. Okay, so now look at the various steps to research process. So the first thing is formulate our question. So we've already formulated our question on how do we solve power issue in Nigeria. Okay. Then we gotta get background information about power in Nigeria. When the Nigeria first have power, start talking. What year? How the power even come in? Efforts made by different administrations to, and then we refine our search topic. By the time we've got a lot of background, our search topic may not be the topic may not be how to solve Nigeria power issue again. It could even be what would it change to? economic building so and so to solve Nigeria's power issue. Right? Good. And then we now consider resource option. Resource is materials. What kind of data are you going to use to the research? Are they available? So these are all you have to consider. And then you will select the appropriate tool. So in this case, if let's say you're writing a program that would be able to know, be able to calculate the effective distribution of power across the country, knowing that okay, Lagos needs this amount of megawatts, Port Harcourt needs. If you're writing that software that will work with the power sector. In that case, you're looking at which tools are you going to use, which languages, programming languages, which tools, hardware you're going to use for the research. So formulate your question. Okay, then the next one is use the tool, locate the materials, then analyze the materials. As you're bringing material, analyzing them, how effective these materials are, you organize and write. And then when you're done writing, you must always have your bibliography. All those materials and tools you use, you have to acknowledge them, the source. So it's very important. So now, this is very important now. Criteria for a good research. So now, if you're here to write your thesis or project, or you want to write a paper, the aim of the research should be clearly mentioned, along with the use of common concepts. Okay, in this case now, what should be our aim? What should be our aim? The aim of the research. Assessing the challenges of stable power distribution. Okay, what could be our aim again? Understanding the challenges for the epileptic power supply in Nigeria. Okay, now the procedures. So we said the aim of this research is to understand the epileptic power challenges facing the power sector in Nigeria. And then the procedure used in this research could be, now, what procedure are you using? You have to state it. And then, in order to permit another researcher to repeat the research for further advancement. So that's why you have to state the procedure you use for the research. While maintaining the continuity of what has already been done. Then the next one, the researcher's procedural design should be carefully planned out. Then you should have your design. So you should have your proposed design. So you have the existing system, what the situation is. Maybe because we are using this architecture in our power grid, that we're now proposing a different architecture on how we can have an effective distribution. So you should have your design. And then the flaws in the procedural design should be sincerely reported by the researcher to correctly make the effects upon the findings. So in the course of your work, if you not notice any flaw in the design, you innocently report that this does that, ABC. However, it is not actually doing this because of the following reason. So that to now be one of the stuffs for further work, for future work. Yeah. So data analysis should be adequate to reveal its significance. So if you actually analyze the data you're using, I mean the percentage of Nigerians having light to places at different times. You're able to gather data. And then when you subject, okay, when you subject your design or when you test your design with the data, you should also write out the results based on what the data is giving you as per your design. The methods used during the analysis should be appropriate. To be appropriate, okay. What am I using? Okay. Reliable and validity of the connected data should be checked carefully. How valid is data? How useful is that data? Not just any data, but data that is geared towards solving a problem. Now, conclusions are needed to confine and limited to only those data which are justified and adequately provided for the research. So now, the conclusion should be, so if let's say now we say, because we want to solve the Nigerian problem, and we can't go around the entire country to gather data about power. So we can also say, okay, let's just use just River State as our sample size. Let's say in Port Harcourt. Now, after using this our design, now distribution was now effective. That so people now have life. So you get. So in our conclusion, we confine it to the data we use. Based on this data, the finding shows that people reverse. We don't say the entire Nigeria now. No, you're confining that to the data you use, limited only to those data, and then justify, make sure that it's adequate as it was used. So in this case, the researcher is experienced and has good reputation in the field of research, and then greater confidence is warranted. So researcher need to have great experience in the field on which you research. And then, so this is just an extra. So this should be, so when you have your abstract, whether you're writing your paper or whether you're writing your thesis, you should have all these things. You have talk about the aim, talk about the procedure, maybe design and implementation of this. We made use of so object-oriented methodology or social methodology. Depending on your department, depending on your field of research, there are different procedures for different research you want to do. So you look at the procedures, look at the different methodologies available in your discipline, and then you have to state that the one you use, with the computer science, you're looking at the algorithms you use, right? Good. And then the design, so all these things should, so the answer now becomes a switching summary of all these stuff. All right, so now let's look at technology. So what is technology? What's technology? Tech. What's tech? What's technology? What's our layman's understanding of technology? Yes?
Technology is application of science.
Application of science. Application of science into innovation. Yes, tech. Okay, so let's look at we're going to start from the etymology. It actually comes from the Greek word techne. This is the Greek spelling. This X is chi, ch in Greek. Where you have chiro, the same ch for Christmas, same for Christ. So that's the thing in Greek. So meaning science of craft. Science of what? Craft. So we are looking at art, skill, cunning by hand. So it's a combination of two words, techne and logia. So this logos, okay, logia. So logia is the sum of techniques, skills, and methods. So when you combine the two words, you have technology. Technologia, and that's in the Greek sense. So the sum of techniques, skills, everything required, all the skills required, methods and processes used in production of goods or services, and the accomplishment of objectives such as scientific investigation. So now, let's say in the course of trying to solve Nigeria's problem, we come up with a device, right? So all the skills, the sum of all the techniques, both our design, the skills, the different methods to use, the processes involved in coming out with that machine is technology. I said like that. Or we can say a set of knowledge, skills, experience, and techniques through which humans change and transform our environment. So we gather all this and then okay, so we've seen this. Now, what's important? Now let's look at this very important. So because we now have a process, we have knowledge to pass. It is written out. So it deepens knowledge. You already know what people have done. It's not just starting from the scratch. You'll be shocked that your solution you have in mind is already done. So now they start looking at the limitations in that work. What they could not do. Now start out from there. So another thing is to help create the future or to mark the progress of all areas of knowledge. Some persons will just come out and tell you that they are refuting the Big Bang theory. Oh no. Or that they are refuting the theory that the earth is spherical and the earth is flat. And they release them again. So we can track the progress of knowledge in that domain. Or okay, they'll say okay that there's a new drug for Ebola, right? And someone has released a paper on that there's a new it's not just someone use our traditionalists there to come up with a drug that can actually maybe cure Ebola, right? But then there's no scientific process, it's not published, nobody knows. So you're just there, yes, you may be healing people, but nobody knows. But they would stay there and then follow the process, put it down, bring out the paper and down. So when you're now doing, you now make reference to in 19 days, so person came out with the drug, proposed something for the Ebola drug. Result shows that people were healthy, 60% of people that were treated got cured. And then you can take off from there. You can now subject that drug to further scrutiny. And now say, okay, so this drug actually does it. However, some patients with so DNA or so things cannot. From there, you now add your own. Right? Okay, so the way to train people to discover the world and understand so then the source of technological and social innovation. Here is the essence of research. Are you serious? Okay. Then, because of the design and developing new products that have increased effectiveness and functionality. So this will enable us to design products methods that have effectiveness, increase effectiveness, because you're adding on what others have done. You're building on what others have done. So there will be increased effectiveness and functionality. So we just keep advancing, increasing. Now developing enhancement and improvement of existing products. So just like those those days, we have cars that their bodies are strong. Some people think all these old people that their bodies are strong and what? When these new cars, their bodies are not strong, right? So why? Why do you think so? Who knows? Uh, yeah. Uh, yeah. All right. So it would enable us to develop new testing methods and protocols. We can come up with new methods of testing, and then improve technologies for manufacturing. Okay. Next slide. All right. All right. All right. Okay. So now let's look at the challenges that we can face. Send it. Explore history, make the trip better. All right. So challenges. Because our time is limited. Now, most of the time we lack scientific training, or even know how to go about this research. Lack of confidence. I'm not able to do it. I'm not able to do it. But let me just do this thing and make my money and go. The field of people is supposed to interact with together, data. Lack of code of conduct. You may not even know the code of conduct to follow while undergoing such research. Lack of funds or assistance or data. Or probably we don't even have enough resource in the library for us to undergo the research. The high cost of publishing. That some people have written, but they've not published because. But then I think that would be the list if you have actually done the research and it's what is left to publish. So what else? So what else? So just look at just a sample. This is actually one of my research works. Let me just open it. I was thinking of something wrong. Okay, because I'm not using my system. So. Huh? No, don't worry, let me. I don't forget like my phone. What's the name of the journal? Okay, let's assume that I want to do research on how to solve power issue in Nigeria. So let's see if there are how many minutes? Okay, so let's say solving power issue in Nigeria, right? .pdf. Let's see. Let's see. Are you saying that people are better doing something? Erratic power supply in Nigeria. Causes and what? Solutions. So you open it, you check there are other works people have done. Erratic power supply. This is, you can see these are actually published in journals. Look for papers. The energy crisis in Nigeria, an overview. So you get as many as possible. Supply was discussed. Factors include government inconsistency, deficiency of power generation, transmission, distribution, and consumption, and the inconvenient workforce of the energy company. Look at the team. This was the factors was discussed. Okay, then recommendation towards solving the erratic power supply was preferred. One of the recommendations was adoption of energy conservative policy, blah blah blah. Other recommendations include, now it was categorically stated that despite the general belief that erratic power supply problem is as a result of low power generation capacity of the country, the major cause of this problem is energy wasted by consumers occasioned by default or estimated billing system adopted by a power distribution company. You don't see this power, can you imagine this? So our problem is not even power generation. Because we're exporting power to not one country alone. No. I said it. So now look at from this research now you actually start having a different mindset. And your solution, you're thinking of maybe power generation and trying to think, no, it's not power generation. From this person's work, you can see the conclusion, contrary to the popular opinion. So when, I hope, have you downloaded it? Okay, those people let us look at it. I hope we just see as many as possible of people have done this. You can see how, you can see the reviews they've done from other works. All right, okay, so they say our time is up. So you could actually, if you want to look, if you're looking for journals, papers, you just add the PDF at the end, 10%, and then you see papers. All right, thank you very much.
All right, thank you so much, Mr. Philip, for such wonderful design presentation and just to really add to that, you also have online sources where online sources like I think Google Scholarly, isn't it? Google Scholarly and all of those things you can use to kind of initiate your pre-research processes, things like looking for the literature review and all of those things and things like that. So these are all add-ons to all of those things. Now, the main point of this, like I said, is not just to come out of this and come out of this as just any conference at all whatsoever. It's about picking out action points where you can go home and apply. So you're seeing problems. These are problems that are prevalent everywhere. We don't just pick out tools and just say, okay, I just want to solve these problems with these tools or that tools, or just the engineering aspect of things pretty much, just the consumption and all of this. How can you develop methodologies that also help other people who are building this? Because I think that's the layer between science and engineering in itself. How can you help? How can you develop tools that can help engineers build stuff? Because eventually, if you look at this, space, it's all about science and technology. But how can you build technology? It's through engineering. So engineering is pretty much the building and designing of technology, and science in itself is the foundation where you need to start the research. Yeah, the research foundation in itself you need to go through before you can build these technologies in itself, and you help build these tools. You help researchers build these tools in this way. So thank you so much, Mr. Philip, and I think we can move on to the next one, which is the contributor talk once more, right? So I'm going to be calling on Kamuno Toyari. Kamuno Toyari was a mentor at, how many of us know Udacity? Udacity. Right, so Kamuno Toyari was a mentor at Udacity. He's also a holder of Udacity Nano degrees, in fact. Udacity Nano degrees, and of course, he was the community manager for That Happy. That Happy is, yeah, so That Happy is actually an all